So as you can see in the graph above, the person with the darker line has a better lactate tolerance because they are able to go at the same speed but with experiencing less fatigue at different rates. The reason the person with the dark line has a better lactate threshold is because they are able to run at the same speed but accumulating less lactic acid whilst doing so. This means the person is going to have a much more efficient anaerobic and lactic acid system. Skeletal adaptations. Increase in bone calcium stores. The calcium in the bones is what gives the bones their strength not to break, and it's produced by osteoblasts. When you exercise, the rate at which the calcium is produced increases, so the long-term adaptation is that the muscles have a larger amount of calcium ions within them. Increase tendon strength and ligament stretch. The ligaments connect to bones or cartilages, or they can hold together joints. The long-term adaptations of these ligaments are that they become more stable because more muscle protein is released, which makes the ligaments stronger and more stable. The tendons are what attach the muscles to the bones to produce movement, and the long-term adaptation of this is that they become stronger with the muscle, so no injury such as pulling a muscle can be done from something such as weight training. Even though the anaerobic training does not use oxygen when it takes place, it can still benefit the cardiovascular system in that it increases the maximum amount of oxygen you can use during aerobic exercise, because the anaerobic exercise can cause muscle hypertrophy to take place, and therefore this increase in the size of the muscle and therefore increases the myoglobin stores, and this means the muscles can have more oxygen within them. The way in which the respiratory system can benefit from anaerobic training is that by doing something such as interval swimming training, it can increase the overall lung capacity, because if you take breathing breaks every fourth to sixth stroke, it means that you will breathe and use more oxygen per breath, and therefore the body will adapt to this and mean that we are able to use more oxygen per breath when doing something such as swimming, where you are forced to breathe less in order to be more streamlined in something such as a sprint. It also means that if we are breathing deeper, then we are also exhaling more waste product in the form of CO2. The anaerobic adaptations. Fast glycolytic fibers. When doing anaerobic exercise, hypertrophy of the fast glycolytic fibers takes place. These are the type of fibers that give us quick and explosive power in the muscles when doing something such as a sprint. The reason that more of these muscle fibers occur is because the body adapts to training such as high-intensity interval training. So therefore, next time this type of training takes place, there are more muscle fibers there that are able to keep us going at a high intensity rate. The fast oxidative glycolytic fibers. These are the type of fibers that are used in something such as a football match, where the intensity is always changing whether you are sprinting or jogging. These muscle fibers can deal with whatever. So if you are a footballer and you are training something such as fartlek training to help you in a game situation, then this will increase the amount of fast oxidative glycolytic fibers that can be used in a game situation. Increased tendon. These are what attach to muscles to the bone, and when you do something such as weight training, the tendons attached to the muscles and the bones become stronger, and this helps you avoid injuries such as pulling a muscle. The proprioceptors. These are what detect movement in the muscles, and when we exercise, the rate at which they send impulses increases because the muscles are having to move so much faster. Therefore, the brain is going to need more constant feedback. This is the short-term adaptation of these receptors. Neural pathways. The way in which the neural pathways adapt to anaerobic training is that they become more efficient at transmitting the impulses along the motor unit faster in order for the brain to receive the information quicker. And finally, the force generation. The way that anaerobic training can change the amount of force you're able to generate is that the amount of fast glycolytic fibers increases, and these are the fibers that provide us with quick, high intensity energy that helps us do something such as a 200-meter sprint.